You are looking at over Unity 38. Another test run on it. Right now, I did some really good modifications in that. Look at that coil down inside there. I've modified. I'm going to run 4 coils simultaneously to show you exactly what I'm talking about. Right there's another one. Right over there's another one. As you can see, there's all 4 of them down inside there. Maybe take a look back this way. You probably see them down below there, hanging down below there. See all those coils? Okay, well, I'm going to fire this up and show you what's going on here. I got each one of them wired up to these meters. I'm going to turn these meters on. Okay, I'm going to run 4 coils. I'm going to show you what's going to happen on this thing. I got to turn these over to the volts a second here. Sorry. I had it on amps. Okay, now they're at volts. Watch what happens. This is what I got putting into it. 2.5 amps or 12 volts. 2.5 amps at 12 volts. Now watch. I'll switch all these over to amperage. Okay, now watch what happens when I fire this up. Just maybe like a 1/4 of an amp more. So it's doing pretty good. Like I said, it shows it's, you said it was up 4, and before it was just a little tiny bit. So it just barely moved that on when I put it on all this on the load. And each one of these, when you put this on amperage, it puts it on load. So I'll switch it back to voltage. And I'll show you what happens here. To fire this up. Tiny bit difference there. Maybe with no load. It's putting out each one of these putting out a different amount. Pretty good now. As you see, all the meters go back down to 0. When it stops, when I fire it up, they'll all go back up. They're not all. This particular one seems to be doing better than the rest of them. I'll just, it's just, that just shows you my inconsistency and what I got going on wrapping this stuff. You know, I just wish I could, you know, had a way of getting it more consistent in that. But I'm working on it. So that just shows you that really wasn't that much. I mean, the meter just barely moved a little tiny bit, and this thing, it's hardly anything at all. You know, I mean, you could just probably put your finger on there a little bit and make that meter move. Watch what I do when I do that. On this little flywheel that I got going on here, I just barely stuck my finger on there and it took up that much magnetic drag in that. So this, if this would be expanded out, you're figuring, you know, a couple volts for each one, but it adds up over a large amount of these things. And that I'm just trying to prove the theory in that behind this, you know. The thing is, it doesn't put out any heat. One of the things, it has very low magnetic drag, and it operates at a very low RPM. That makes it something really special. I mean, it's not going to be anything that's going to revolutionize and knock Tesla all out and all that. No, that's not what it's going to do. Basically, I'm working on something that can actually tap into these low energy sources like a river, fast moving stream, like ocean currents, or even wind power. You could build a real small windmill and use it to charge up your car or something and drive it instead of having, you know, I mean, if you take a look at those windmills, they got millions of dollars in them, believe it or not, you know. And I don't know what they put out, but that's a lot of money, you know, when you consider that. But I'm just trying to get these things to come down inside here. I got some different magnet wire. Let me take a look over here. I'm going to try this. I'm going to try this 20 gauge right here. I don't know if you can see it right there. It says 20 gauge. It's probably not very clear, but this is 20. I'm going to go with a little bit thicker wire. It seems like the thinner the wire it is, the more magnetism it creates down inside of here. The thicker, it seems like the less magnetic drag. I'm going to see if I could speed it up a little bit faster and get a lot more current out of it. That's what I'm working with right now. But I'm just trying to prove that maybe we could possibly tap into these other energy sources. If you're getting, even if you're only getting a couple few watts out of each one, still that's considering the magnets, these permanent magnets, there's not that much use. But if you buy them by the millions of them, you're going to get a big discount on them. You know, I know they're kind of expensive, and this could be easily injected with plastic. All this could be all made out of plastic and put together, and very easily made up to generate power. The other thing I want to say is, it's just like a thunderstorm. You know, as the raindrops brush across each other, you know, each one of them adds up, and you get a lot of power. I mean, you know, out of even you could even tap into small lakes, which just don't have the pressure to push the generators and to run it to get those high RPMs. This isn't running very fast at all. I mean, you know, you could, like I said, you could just pull this over like that, and you know, I could just barely pull this over, and these things are jumping down inside of here. They're moving. I mean, and it's not, you know, going to take that much. Somebody said something about a water wheel and that. Well, I don't know how you're going to generate power from it. It's going to, it's going to have to be a pretty big wheel. It's going to have to be pretty huge to get those RPMs up in that. I'm just trying to come up with a better way of generating electricity for our needs and stuff, and it's clean, economical, and it's not going to be damaging to the environment. That's the whole ideal of this project. And that, as you can see, there's a lot of machining in that. There's, I mean, this isn't just your typical person that puts something like this together. And that, I mean, you could see that it's quite involved in that, with the counterweights and with these weights in between here. You can see how it's just coming by here and just tripping this. So it's not going to take that much energy. And what the beauty about this is, when it oscillates down inside of here, it will stop when the magnetic drag gets gone too much. So that'll tell you that this lever arm will stop. So then you got to keep adjusting the coil. Otherwise, if you had something that wasn't going through these magnetic fields and that, you wouldn't know how to adjust your coils. You're just going to be fighting a thing called magnetic drag. It also doesn't have electricity to make electricity, so that's another plus on this here. You're not going to be, these magnets will stay charged. You're not going to be using electricity to make electricity. That's loss. When you do that, it changes it into a magnet, but also the energy changes into heat. So energy cannot be created nor destroyed, so you're going to be doing something with it. And this is, hopefully I can prove that it's going to be more efficient. And we're going to start tearing this other one down and start rebuilding it over here. This is the commercial unit. I got some, to get it to that point. See how much higher those orbit heights are and how low these are. I'm going to have to tear this all down and make some adjustments in that. From I learned off that, I'm going to eliminate these springs in the bottom here and kind of move everything up into position and then put it together. And then I'm going to see how much it takes, how much power. So I'm going to go along with, so somebody said they want to know what's the input and output. Okay, I'll be front forward. I want to do that because I want to try and use this in hybrid cars. I still don't have it quite all developed yet. I know everybody's going to be out there that say bad things about it, but I don't care. I'm just moving on with it. It's coming together, and I think in some time later on down here, it's going to really show how it works and that, and it's going to be a real beneficial way of generating electricity for our needs and stuff without having to use these high RPMs and this magnetic drag and try to get something that I could prove that it's a very, very high efficiency. That's my goal of this thing. So I'm just going to run this one more time, let you see it. I got some different coils, but like I said, there's some magnets down there in the bottom. That's the reason why when it comes down in there, it kind of pushes it out. It keeps the orbit height from slamming in between here. And that's it. So I'm going to fire this up and let you see it one more time, and then we'll call it quits.